Relations as functions. A function is a relation in which two elements in the domain, also called the inputs, of the relation correspond to exactly one element in the range, also called the outputs of the relation. An easy way to consider this is if you have four different students, Bob, John, Bill, and Mark, they have three different ages between them. Bob is 18, John is 20, Bill is 21, and Mark is 20. So when we say a function is a one-to-one relationship, this is actually a one-to-one relationship because Bob can only be 18. Bob cannot be 18 and 20 at the same time. It's just not possible. While it's fine that John and Mark are both 20, they couldn't be two ages at the same time. So this example represents a function because it's a one-to-one correspondence. So f of x, this is the notation you see up here. Functions are often denoted with letters lowercase f and g and then uppercase f and g, etc. If f is a function, then for each number x in the domain, the corresponding value in the range is denoted f of x, and the way you read that is f of x or f at x. It does not mean, it's not multiplication, it's not saying f times x, it's saying evaluate the function f for the value x. So f of x is the value of f at the number x. The value x, or the variable x, is the independent variable, meaning it can be assigned any number that belongs to the domain. It's independent. The f of x is your y, or your output, and this is the dependent variable because it depends entirely on the value of x, or what is plugged into x. So the x is input into the function and the y is spit out. As we know, all functions can be graphed, and the graph demonstrates the behavior of the function. So a function, or to be a function, it goes one step beyond just being a simple equation. Being a function means that it has a one-to-one correspondence from the domain to the range, but it also means that it passes the vertical line test. Exactly why is that? If you look at a graph, the x values can only map to one y value. So if you draw a vertical line, you should only touch that graph at one point. So the vertical line test says that a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So this function you see here, specifically a parabola, a quadratic function, it is indeed a function because that vertical line drawn anywhere through that graph will only intersect the graph at most one time. Given a graph like this is not a function because you can see that that vertical line hits the parabola two different times. So this is not a function. It is not a one-to-one relationship from the domain to the range. Also, we have a circle. If you have a circle, you can draw a line anywhere through that graph and you're going to intersect at least twice. Twice for sure. In some cases, maybe just once. You might only be tangent. So this is not a function. Now, finding the value of a function, what does it mean to evaluate a function? So for the function defined by f of x equals x squared minus 3x minus 1, evaluate, for part A, we're evaluating f of -2, and for part B, we will evaluate f of x minus 4. Starting with part A, to evaluate a function for a specific variable, it means to replace that variable with that number. I strongly recommend starting by replacing the x values with parentheses. That way, if in this particular case we have a -2, so if we're plugging in a negative number, there's no confusion as to whether that negative sign gets squared or not, because if it's placed inside the parentheses, it's very clearly getting squared. So start by replacing the variable or replacing the x with parentheses first, then fill in those parentheses with the number, in this case, -2. Then watch your order of operations. So here, our order of operations say -2 squared has to happen first, which gives you 4. Then you have -3 times -2, which gives you a +6, -1. Order of operations says to always read this from left to right. So we take 4 plus 6 is 10, -1 is 9. So when you evaluate the function f for -2, the result is 9. And to take that one step further, if you were to graph the function x squared minus 3x minus 1, you would see a point at -2, 9. -2, 9 is a point on the graph, because we input the value -2 and it output a 9. Next, we'll do the same for part B, but we're going to evaluate it for x plus 4, which is a little bit more to handle than just the -2. Again, replace the x value with parentheses first, then drop in the x plus 4. So now, one thing to be careful of, the x plus 4 squared, you actually have to FOIL that. So x plus 4 times x plus 4 must be FOILed, which is where the x squared plus 8x plus 16 comes from. Then distribute the -3, so you get -3 times x, or -3x. And then -3 times +4 gives you a -12. And then finally subtract off the 1. Next, we combine like terms. So the x squared is by itself, but then we have 8x minus 3x, which is 5x. Plus 16 minus 12 is 4, minus 1 is 3. And it's perfectly fine to end up with x squared plus 5x plus 3. This is perfectly acceptable. You're not always going to be able to break it down to a number. If you're inputting a variable and a number, in other words, in this case we input a binomial, it's not going to break it down for just a number for you. So f of x plus 4 is x squared plus 5x plus 3.